Ave Coders. In this lesson, we'll have a look at the so-called magic methods. You can easily identify them by the double underscore prefixing and postfixing their names. So let's get into code. Alright, I'm going to be using VS Code with the Python extension, and I'll build on what we've done in the OP lesson. So if you haven't seen it, so go and watch it first, so to understand what's going on. All right, so the first magic method is called str and is basically responsible for string representation of our object. Please pay attention at the double underscores prefixing and postfixing the method's name. And if before, as you remember, if we would instantiate the object of that class and would attempt to print it, we would just get an address of that object in memory. However, if we'll do the similar operation now after overriding the str magic method, we will get a nice human readable representation of that object. So let's have a look. So car1 is an instance of the car class and is going to be Toyota, let's say Camry, and we're going to define the price as integer, something like 7,000 units of money. And also for comparison, we'll instantiate a new object of car2 of a class car, which is going to be Opel Mokka, and it's going to cost us 14,000 units of money. And let's do a bit of an experiment first and comment out the str, just to remind ourselves how the representation of the object looks like without this magic method. We can't see anything because we haven't used the function print. Okay, so let's print car1 and car2 and have a look. So we'll get just an address of that object in memory. Not that nice. And now let's see what's going to happen when we'll uncomment the str magic method and run it again. So as you can see, we get a nice string representation of the object's attributes, which is the name, the Toyota, then the cost. All right, so this was our first magic method, str, but there's another one. It is called a wrapper, and it is responsible for string representation of objects' attributes as well. The difference? Well, according to the official documentation, wrapper is used to compute the official string representation of an object and is typically used for debugging. And if you want to learn more about the intricacies of this magic method and the difference between str and wrapper, I will advise you to head to the official documentation and have some fun there. We'll observe the effect and some use cases for these magic methods on our object. And we can actually call these methods when we invoke the wrapper and str functions on the object. Str for car1 and wrapper for car2. And as you'll see, the output doesn't look too different. Now, it's not only about this human readable representation. Let's have a look at the comparison, for instance. Let's say car1 and car2 will be compared using the double equal sign. So we can see that the car1 and car2 are two distinct objects, but we can just look at their attributes and see that they are slightly different. They have different values. And if we'll compare them using the double equals, then we will rightfully receive a false. But as we see, car2 and car3 are two similar objects. So if we'll compare them, they do have the same values actually. Opel Mokka and the price is the same. But we also get false. Why is that? Well, this is because it compares the objects as their addresses in memory. It doesn't compare their representations. So we need another method called EQ for equals or equality to make sure we can compare two objects. And inside this method, we need to specify which values are we going to compare. So in this case, it's going to be make, model, and the price, so that it will at least know the criteria for comparison. In this case, a value argument represents the object we are going to compare the first object with. So it will sequentially compare make, model, and price of two objects. We also use the AND keyword to unify all these statements. And it will also be helpful if we'll add some kind of a conditional here saying that if the instance of the method we will compare with is not a car class, then we will not compare them. We will raise value error because we can't really compare something that is not of the same class. So we're going to print can't compare because of the type mismatch. And this is a logical thing to do because if we will be comparing, say, a car and a music instrument, then it will make no sense. So now, if we look at the result of comparison of car 2 and car 3 via the double equal sign, then we will receive true because essentially car 2 and car 3 confirmed they are the same entity. And of course, the comparison of two separate entities will still return false, but this time the interpreter goes into what values do their attributes hold instead of just comparing their addresses in memory. So this is how we compare basically whether the two instances of the same class have the same values as the arguments. But how do we compare that something is, say, bigger than something else or smaller? And luckily, there is a magic method for each of these cases as well. Actually, there are more than what we're going to show in this lesson, but please feel free to check out the docs. I can't see any sense to, showing them all here. So I'm only going to show you two of them. First one is more than or equal to, and the second one is less than. However, here is the question. How would you compare what is bigger, opal or opal? You need to know some kind of a numerical, let's say, metric. And in our case, the only metric here is the price. So if your class would have, for instance, many more attributes, you can add, I don't know, the engine capacity or the engine power. But in our case, we do have a pretty simple class, so we only going to compare them by the price. So the magic method for comparing what is greater than or equal to is GE. And we're going to put this check here as well so that we compare two instances of the same class. And down below, we gonna specify which attribute we're gonna use in our comparison. So in our case, it's gonna be, of course, the price as the only numeric attribute. So return self.price is greater than or equal to value.price. All right, so that was greater than or equal to method. So now we're going to do the less than method. Somewhat expected, the method that opens this functionality to define which instance of the class is less than or just less than. The other one is called LT for less than. And once again, we pass self and value. And we do the check, making sure we compare two instances of the same class. And similar to the previous method, we only return self.price less than value.price. Self.price is less than value.price. All right, so let's try to run them. And we have attribute error. Of course, it's not print, it's price. All right, so now you might be asking, that's all neat, but how we can use that in real life. What is the practical applicability of these methods? Well, what it actually gives us is the ability to compare objects. So now we can, let's say, we can make a list of some objects. I'll comment them out. So let's imagine we are running some car dealership. So we have some cars. I'll represent them in a list. So car 1, car 2, and car 3. And for the sake of this example, let me change the car 3 slightly. So let me go to the car 3 and I'll swap Opel for some other value. Let's say it's going to be some unknown maker. And it's going to be, I don't know, junk wagon. And it's going to be just a few bucks. And let's say someone wants to see the offers cataloged by, let's say, price from lowest to highest, which you can normally do on any decent car dealer website. I'm not saying that it works the exactly this way, but at least you got the point how we can use that. So we use sorting, and then we're going to print the sorted list of cars. So the cheapest first, and we're going to iterate by this list and print cars by makers. So in other words, we'll not display the price, we'll just display the not the makers, doesn't make sense, let's say model. And if we'll run the code now, we're going to see sorted list, and junk wagon comes first, then Camry, and then Mocha. Press the like button if you have ever had any of these cars. All right, so these were two of these comparison methods. By the way, there are many more of this type of methods, as well as some math as well. You can check out the documentation if you want to learn more. But we'll move on, and the next topic I want to talk about is the topic of control. What magic methods also allow us to do is to specify how the attributes are going to be accessed. In other words, inside of a class, we can specify these interception methods. And every time we'll want, for example, get the attribute or set the attribute, it will specify the behavior. So in this case, we will start with the get attribute method. That will essentially allow us to manipulate the value of the attribute price before we'll return it. Let's say in this example, we want to apply the discount to the price. And we want to do that automatically every time the value of the attribute's price is retrieved. So the first line, if name double equals price, makes sure that indeed the price attribute was accessed. But here's the thing, because we are already inside the method that is going to get called every time the attribute is going to get accessed, if we will simply refer to the object's attribute by its name, then we'll get stuck in an infinite loop until the program will crash. So we can escape that by calling the parent of get attribute method with the price and discount. And we'll store the returned values in variables p for price and d for discount. And in the end, we'll perform the math, and this will make sure that every time we access the price attribute, we get a discount. But we also need to specify what's going to happen if the attribute that was accessed is not actually price. So we just return the name of the attribute. So once again, the parent of get attribute with the name. All right, so down here, we'll start to manipulate our price. And let's say we offer to swap the old car for a new car, or for a discount to buy a new car. I'd say it's a fair deal. So we're going to access the attribute price on car1 via the dot operator, and we're going to set it to 7,500 units of money. And then we'll just print the car1. That will trigger the str magic method, so we'll get a nice human readable representation of our object car1, which is, we need to comment that out. And we can see that it is Toyota Camry that costs now, the discount was applied, so 5,625. Nice. All right, so this is how we get the attribute, but we can also set the attribute as well. There is another magic method responsible for setting the attribute, and it is called surprise, surprise, set attribute. So let's move back to our car class, and just down below the get attribute, we'll specify the set attribute. But this time the name is going to be a little bit shorter, so it's set attr instead of attribute. And let's code the behavior so that when someone is setting the, let's say, price value, we must have it in float. So we do a condition here as well. So if name equals price, making sure we are modifying the right attribute. And here we check the type of the value of that attribute. And if it's not float, we raise the value error saying like price must be float. And once again, if the attribute is not price, we will just return the name of that attribute. So we'll access the parent of set attr, so super set attr, and the name and the value of non-price attribute. All right, so down below, let's try to modify this line. Actually, let's try to run it first and see if we can get the error. Yes, we have an error, value error, price must be float. So if we'll modify the value to something like 7,550, which is a float, but we still get the error. And this is because at the top where we initialize the object, we specify the price as an integer. Now that I've commented them out, I will reprint the object creation down below. Let's say we want the same Toyota Camry, but this time the price will be not the integer, but it's going to be of type float. So I'm going to add, let's run the integer first, we get the error. And now if I'll modify the price and I'll add a 0.50 to make it float, we get everything working. There is another way we can specify that the value is actually float, is to cast it to the float. So this will work as well. And not only we specified the value for the price attribute via the set attribute method, we also get a discount on that price via the get attribute. However, if we'll try to access an attribute that doesn't exist, let's say engine, we're going to get the attribute error that car object has no attribute engine. And as you might guess, there is another magic method to handle these situations. Its name is a shorter version of get attribute method known as get attr. So this method gets called in one of the following situations. Either when get attribute method does not exist, or it raises an error, or when we try to access an argument that doesn't exist in this particular class. So it will just return the name of the attribute and a message that this is not implemented, and that should be enough. So engine not implemented, we'll just have to maintain a space. So the attribute engine is not implemented. And another handy and yet pretty straightforward method we will look at is called call. In short, what it does is it enables Python objects to be called like regular methods. All right, so let's go over here and we'll specify this magic method call, which can take either the variable number of arguments, that is what autocomplete is trying to convince us to do, or it can take or replicate the arguments that exist in the init method. This is what we're going to implement for this example, which means that we can use some of the copy and paste magic and just copy these arguments into the body of that method. And down below, we're going to look at a few examples of what we can actually do with objects in Python. So as you know, car1, the very first line is the standard implementation of this car class we had a look at previously. And then we print this engine, which will comment out. But then what I'm typing now is actually a tuple. So in other words, car1 will now contain a tuple. And the behavior is going to be as if we would work with tuple. So let's launch it. We need to change the print statement. So we'll just print the car1. And I'll copy that statement and paste it underneath the tuple. So print car1, and you'll see the difference. So the first statement is the values of arguments of the genuine instance of the class car, and the second statement, these are just the values in the tuple. But this representation might be deceptive because it does looks like the values of arguments of the instance of a class car, but it is something totally different. But what the call magic method actually allows us to do is we're going to use it right now. We're going to actually call the instance of that car1 of the class car as a simple function. So in this case, I'm going to do car1, and let's say it's going to be Porsche, Carrera, and some money. And this is, of course, needs to be float because we have a set utter method that checks on that condition. We're going to copy that print statement as well. And actually, when we'll try to run it, we'll get into an error. Thanks to the tuple conversion, car1 is no longer an instance of a class car. So it's going to error that the car1 is now a tuple and tuple is not callable. So this is how dangerous and deceptive the reliance on just the print statements might be, because, as I've said, they do look similar. I mean, the representation of the values of the car1 as an object and then as a tuple. So we're gonna comment them out. The car1 as the tuple, we don't want that anymore, so we'll comment that out. Just a handy tip in case you didn't know, so you can actually select the lines you want to comment out and then press Ctrl and add /. And now, as you can see, it works as it should. And just before we'll wrap up, I'll show you another trick, which is not really a magic method, but it's still very handy. But before that, I'll remind you that the code from this lesson is available in Ave Coders GitHub repo. So our next guest is not really a magic method, but rather it is an attribute of a class. written with the double underscores as well. So it dict, and it contains the dynamic attributes of an object. So if you want to, let's say, use it with a car1 and then by the dot operator call dict, so it will print the attributes with their corresponding values, which may be a really helpful tip. And we're going to probably look into them in a separate lesson. So make sure you subscribe to this channel and you press the bell icon so you won't miss any more lessons. And please give this video and press thumbs up. That was V. Thank you and goodbye.